Welcome to Real GMAT Problems, episode 40. Doing real GMAT problems is one of the surest ways to make test day go well, so let's talk through a few examples. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions that we're going to work through here. The official guide contains retired problems that have appeared on past GMAT exams. So these are going to be really similar to what you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on what I recommend learning from each question. I recommend pausing after I read through each problem and trying to solve it, or at the very least, if you're on the go, visualize how you would solve it. Might not be able to get through all the steps in your head, but it's a great mental workout. If you are in a situation where you could physically write down what you would on test day, that's definitely ideal. Once again, we've done a lot of problems in this series so far, so it's time to tackle some of the more difficult ones. I'm still going to begin with a simpler warm-up problem, but then I'm going to ramp up the difficulty much more than I have in the past. So if you're finding the later problems a little too tough, you might want to go back to some of the earlier episodes and return here when you're feeling ready. Let's start with our first question. In a set of parentheses, we've got square root of 2 plus 1. And then that's multiplied by another set of parentheses, inside of which is square root of 2 minus 1. Then we're also multiplying that by another set of parentheses, in which is root 3 plus 1. And then we've got a fourth set of parentheses, inside of which we've got root 3 minus 1. So I'll walk through all that again so you can visualize it. But it's basically in parentheses, root 2 plus 1 times in parentheses, root 2 minus 1 times in parentheses, root 3 plus 1 times in parentheses, root 3 minus 1. So within the first set of parentheses is root 2 plus 1. So it's root 2 plus 1's inside the parens. Then in the second set of parentheses is root 2 minus 1. And then in the third set of parentheses, root 3 plus 1. And in the fourth set of parentheses, root 3 minus 1. All four of those things are being multiplied together. And then it just gives us an equal sign and some answer choices. So we're going to go deep on roots today. Option A is 2. Option B is 3. Option C is 2 times the square root of 6. Option D is 5. And option E is 6. And as always, I recommend pausing here and doing your best to solve. We've got an excellent warm-up problem here that illustrates some really valuable points about roots questions in general. First, a lot of roots questions are very content related. And if you're not rock solid on the basic rules of roots, it's very, very worth practicing those. In fact, we've got a math basics episode to get you up to speed on the essentials. And from there, you should be able to use a Gen AI tool of your choice to ask some basic practice problems. Unfortunately, a lot of free Gen AI isn't super great with the complexity of GMAT level questions just yet, but it's pretty good for getting some short drills down on just like the basic concepts. For example, it will often make mistakes or tell you some wrong things if you're doing like full level GMAT questions there without being like a power user of Gen AI tools. And if you're already a power user, you've probably figured out some workarounds for that. But if you're using the free product, it's not that you can't get value out of it, it's just you want to use it in the right way, if that makes sense. So at least for now, I don't recommend Gen AI for simulating real GMAT questions. And that's part of the reason we're putting together this series for you. There's nothing like the real thing, at least for now. But that tech is very likely to get to a good level at some point, and we'll do our best to keep all of you up to date on that. For now, we're just going to stick to real problems together with me reading them. But even though the free Gen AI tools are not so great with the complexity of the questions that you and I are going to talk through today, they're pretty good with a prompt like generate 10 short questions about roots that will help me practice the basic skills needed for the GMAT. So you want to make sure that you tell the AI, like, I just want basic skills. I don't want full GMAT problems. And if you ask for 10 GMAT roots questions or something like that, you're probably going to get some material that's pretty off base and maybe even wrong. So I don't want that to happen to you. But just for drills to practice like basic manipulation of multiplying roots, adding roots, subtracting roots, that kind of thing, some free generative AI chatbots are a fantastic use case for something like that. And of course, if you have a paid provider that has material on that stuff specifically, that's also great. But just in case you're in the boat like a lot of us were back in the day when I was in your shoes, just doing this for free or trying to keep things low spend, then that's a free path that you can take. So classic web search can work also, honestly. For example, there's a lot of good math basic material on YouTube, and you probably don't need a ton of practice questions on the core concepts with roots to get where you want to go as far as like the level you'll need for real GMAT questions. So that's what I recommend. Some free Gen AI or just a classic web search. Good news is I'm going to focus on some of the content of these questions more than I would with other topics today in our lesson right now. So you should have a strong head start going into your practice on the basics if you feel like you need it at all. Some of you are going to be a little bit more advanced, and that's cool too. So that's the first reason that this is a good warm-up problem. It has some content issues that are worth discussing, and it's not just about how you're executing. It's more knowledge-based than that. Don't get me wrong, like the how you're executing matters, and we've talked about that just an inordinate amount in this series so far. Um, but I did want to focus a little bit more on content because, yeah, all the reasons I mentioned, and like I think you'll just find it helpful. I think you'll be really glad that you tuned in. So the second reason this is a good warm-up problem is that it represents some patterns that come up pretty frequently. So it's going to be a good opportunity to introduce those patterns, and then I think you'll find those super useful as you move forward with rates and more real GMAT problems on your own. They'll also come up later in our lesson as we get into some more difficult questions. So let's hop right in with all that being said. As is often the case with GMAT problems, there's a few solution paths here, but I'm going to focus on the path that uses a concept called FOIL, F-O-I-L. FOIL stands for first, outside, inside, last. And it's a common way to deal with something called quadratic equations. We've got a whole math basics episode on quadratic equations linked for you below if you'd like to upskill or reskill with what quadratic equations are all about. What I'm going to do here is I'm just going to use FOIL twice. I'll use it on the first set of expressions that contain root 2, and then I'll use it again on the second set of expressions that contain root 3. So let's walk through that. I'll start with the root 2 expressions. I'm going to assume that you understand the FOIL concept here, so please, if you're not sure what I mean by that, just check out that Math Basics episode. It's linked in the description for you on quadratics, and then just return here whenever you're ready. I don't believe that quadratics Math Basics episode is terribly long. You probably get through it pretty fast. So we've got root 2 plus 1 times root 2 minus 1, and I'm just going to focus on that piece. First times first gives us root 2 times root 2, which is just 2. If you need the super basics on roots, I'm just going to remind you, also linked below is the Math Basics episode on roots. So if you're really new and you're just starting out, then I'd recommend going there and then coming back here after that. So first times first is root 2 times root 2, which is 2. Outside is root 2 times negative 1. So remember, I've got root 2 plus 1 in the first set of parentheses and root 2 minus 1 in the second set of parentheses. The outside terms are root 2 and negative 1. So I multiply those, I get negative square root of 2. The inside terms, that's 1 times square root of 2, so that gives us positive square root of 2. And then the last times the last gives us 1 times negative 1, which is just negative 1. So we'd wind up with 2 minus root 2 plus root 2 minus 1. And because negative root 2 plus positive root 2 equals 0, our net result is going to be 2 minus 1, which is, of course, just 1. So that whole set of the first two expressions, root 2 plus 1 times root 2 minus 1, just winds up equaling 1. Now, I'm going to do something similar with the root 3 plus 1 times root 3 minus 1. I'm just going to do first times first, outside, inside, last. Okay, so first times first is root 3 times root 3, which is just 3. Outside is root 3 times negative 1, which is negative root 3. Inside is root 3 times 1, which is positive root 3. And then last is 1 times negative 1, which is, of course, negative 1. So we'd wind up with 3 minus root 3 plus root 3 minus 1, which ends up just being 3 minus 1 because negative root 3 plus positive root 3 is 0. And 3 minus 1, of course, is 2. So we've simplified the first two expressions, root 2 plus 1 times root 2 minus 1 to just be 1. And then we simplified the second set of expressions to be root 3 plus 1, root 3 plus 1 times root 3 minus 1. We simplified that to be 2. So we basically wind up with 1 times 2, which is, of course, 2. And that gives us our correct answer, which is option A, as in alpha. Like I said before, there are plenty of places where you might make a math mistake there, or you might write something down improperly. But I think if you know the content, there are fairly strong odds that you're going to be successful on this particular type of question. I know we've talked a lot about scratch work and writing things out and organization on previous problems. So I'm hopeful that if you've been a medium or long time listener, that you've built some good habits there. And if you're just starting out and you're making those math mistakes, that's totally normal. What you want to do is just keep track of them and make sure that you're truly reminding yourself every single study session to recondition some new habits to prevent those mistakes. And if you go back and listen to those episodes, I'll walk you through some good organizational techniques you can use on more complicated word problems and translation questions where like people tend to get a little bit more mixed up organizationally. With these quote unquote pure math, like roots, exponents, equations, algebra questions that don't involve like a lot of word organization, you can still make mistakes. Like here, I can imagine people mixing up some negative signs. So again, just keep track of that and remind yourself every single study session to build the new, better habits, such as like writing out every term as you FOIL. You heard me talk through every term that I would have written down, and that's a lot more robust than what I see a lot of people doing. A lot of people are trying to do a lot of steps in their head, and I've even seen a lot of GMAT professionals recommend that their clients get good at doing stuff in their head. And I'm not trying to step on anyone's toes here, but I just have not seen that work super well. I think you're probably going to get a lot better results just writing things down, and you're going to get those results a lot faster. Obviously, it's up to you. You're your own person, but that's my advice. Having gone through like I don't know, tens of thousands, maybe hundreds of thousands of data points at this point. I've seen a lot of people do a lot of GMAT questions, everybody. Oh man. So trying to share that insider knowledge with you as simple and I don't know, maybe even like obvious as that might sound. Now, with all that being said, um, I think the main bottleneck for people here is probably not making scratch work errors. It's probably that they're not knowing what to do, or they're getting to a certain point in the problem and then kind of getting confused. That's my guess on something like this. So you'll want to be comfortable with things like how to multiply roots, how to add and subtract roots, how to do things like FOIL. That's what I'd call more knowledge based than like the execution based stuff I was just talking about a moment ago. So it might be a good idea to re-listen to some of those basic episodes, like I said, especially if you're struggling, um, or potentially make some notes to self to help you remember the basics. I think those are kind of the main punchlines of this question. Otherwise, if your basics are solid, you were probably good to go on that one. But if you do need some new habits with tracing your math through multiple steps or not mixing up negative signs, then I'd invite you to make a quick note to self on that. So if you're on the go, I'd recommend pausing, just like text or email yourself something to make a note later in whatever note system you're using to track your GMAT facts and figures knowledge. And then we'll jump into a question that by the numbers is quite a bit more difficult. Okay, this is our second question. The question says, for which of the following values of x and then we've got a bunch of square roots and parentheses again. Okay, so I'm going to do my best to describe this as well as possible if you're on the pure audio feed. So we've got a giant square root symbol over a expression with three terms in it and a lot of parentheses. So we have a giant square root over 1 minus the square root of, in parentheses, 2 minus the square root of x. So we have three square root symbols total. We've got a big one, which is covering the entire thing I just read. So it's square root of everything I'm about to read to you. And then inside the parentheses under the square root is 1 minus, and then the square root of, also in another set of parentheses, 2 minus the square root of x. So I'll work from the inside out. So we've got 2 minus the square root of x in the kind of like most inner term, and then we're taking the square root of that whole expression. So it's square root of 2 minus the square root of x. Visualize that for a second. Then we're subtracting that value from 1, and then we're taking the square root of that whole result. So that's why we have that giant square root at the top. So what they're testing here is your ability to work through nested square roots, like the square root within the square root within the square root. So it is a very meta problem here. Okay, so it's all that. I'll read that one more time. And I know this might be a little cumbersome if you're on the pure audio feed, but I think you're going to find it more than worth it when you sit down to get back to your GMAT prep at the desk. Yeah. So for which the following values of x is that whole thing I just read, not defined as a real number. So we're trying to figure out within that expression, there are 5 values of x I'm about to read for you. Which one of them would not result in a real number? Option A is 1. Option B is 2. Option C is 3. Option D is 4. And option E is 5. So I'll invite you to pause, get as far as you can on your own. I'm going to read the expression one more time. It's square root of 1 minus the square root of 2 minus square root of x. So again, recommend pausing. I'm just going to jump into my commentary. So quite a bit tougher by the numbers, like I said before. About 4 times as many of us get this one wrong versus the previous one. Yeah. So let's dig into why that might be happening. And we'll get some course correction going because I truly believe all of you are capable of getting this question right 100% of the time. We might just need a little bit of knowledge and a little bit of good habit building. I think this one is also a content issue. And I'll try to explain that using some of the wrong answer distribution. So it looks like a solid number of us end up picking option D as in delta, which unfortunately is not right. But it looks like that's happening because people are plugging in 4 for X. So recall A is 1, option B is 2, option C is 3, option D is 4, option E is 5. So people plug in 4 for X, then they take the square root of 4 to get 2. And so in that innermost set of parentheses I was telling you about where we have 2 minus the square root of X, it looks like what's happening there is people are plugging in 4 and doing 2 minus 2 equals 0. And then they're taking the square root of that, and they're thinking that that's not a real number. That's my guess as to why so many of us are going for option D. Now, if it's been a while since you thought about what a real number is versus an imaginary number, first of all, that's extremely understandable. Most working professionals are not walking around thinking about real versus imaginary numbers on a regular basis. Certainly not if you're in the business world. And real numbers just mean no square roots of negatives. In fact, we've got a whole math basics episode on those definitions. That'll also be linked for you below. The important point, though, if you don't want to go through all that right now, is that 0 is not negative. And that's part of the reason we led off the GMAT Math Basics series with so many definitions, because it's I mean, it had been a while for me when I was starting to study this, like a long time. So I'm just making the stuff that I wish that I had back then for all of you. So the square root of zero actually is a real number. And again, I'm just defining real number as no square roots of negatives. If I take the square root of zero, then I still get a real number. And that's because zero is not negative on the GMAT. It's neither positive nor negative. So again, we're kind of getting into these like weeds of definitions. That's why I think this question is very content based and probably a little bit less about execution. So if you think about it, square root of zero equals zero should make at least some sense because when you take the square root of a number, you're looking for something you can square, meaning multiply by itself, to produce the number under the square root sign. So that's why the square root of 4 is 2. 2 is the number that if I multiply it by itself, it generates 4, which was the original number under the square root. So when I say square root of 4, you might just intuitively think 2 because you've like done that operation so many times. But if you think a little bit deeper, you're like, okay, what number can I square to make 4? Oh, that's 2. So think about that for 0. 0 is the number that if I multiply by itself, I get 0. So the square root of 0 is 0. Again, GMAT defines 0 as neither positive nor negative. So taking the square root of that is allowed. So again, pretty definition heavy there. And I think that's probably why we're seeing some confusion on this one with people thinking square root of 0 isn't a real number. So again, super understandable. If you're going to make that mistake, definitely make it in practice. And that's an opportunity for you to get it right on the real exam, which is a huge, huge focus of our time here right now. We really don't care what happens when you're, on the out whatever you're doing here, or if you're watching at home. We care more about what happens on test day. So even if you got everything wrong in every study session, but you got it all right on test day, like that would be good work. So all that being said, that's all reason to try to clean those knowledge gaps up together since like the previous question, once you know that content, you should be much better equipped to get these kind of questions right in the future. So that's why it's not option D. Interestingly, you might suspect, if you think about it, that another popular option is A, even though that one also is not right. In fact, A is about 50% more popular than D. So let me explain why I think we're seeing some similar confusion there. My guess is what's happening is, remember, A is the number 1. So people plug in 1 for X. They take the square root of that. Square root of 1 is just 1. And then they do 2 minus 1 in that innermost set of parentheses to get 1. And then they take the square root of that. And then they get 1 again. And then remember, inside of the largest square root is 1 minus all the stuff we just computed. So they get 1 minus 1. And then that ultimately leads to square root of 0. And then unfortunately, I believe they come to the same conclusion that square root of 0 is not a real number. And it looks like about 13% of us are doing that. If I had to guess, I would say that more people go for A rather than D, simply because it's just the first answer, and they're probably just starting with A, plugging in 1, getting square root of 0, and thinking like, okay, cool, that doesn't seem like a real number to me. So if we assume I'm right there, that means 21% of us believe that square root of 0 is not a real number. So again, just a content issue there. I figure it's easy enough for us to rectify that as a group. And so let's just go ahead and make that note and remember that if we're going to make mistakes, it's best to make those mistakes in practice. Many of you probably already figured out that the right answer is E, as in echo, which if you didn't get there is 5. And just quickly, the reason that works is that the square root of 5 is bigger than 2. So if we plug in 5 for X, we hopefully would realize that subtracting something larger than 2 from 2 in that innermost set of parentheses would yield a negative value. And that is going to mean trying to take the square root of a negative value, which is not allowed on the GMAT because square roots of negatives are what are called imaginary numbers. And we don't worry about imaginary numbers on the GMAT. They're basically like not allowed. They're like out of bounds. You could think about it like if you're playing a soccer game and you kick the ball out of bounds and then you run over there and you like grab it with your hands and throw it into the goal. That's not going to count. So that's like imaginary numbers on the GMAT, not allowed. So that's what this question's really getting at, real versus imaginary. That's really the key. Just learning to recognize that the square root of negatives aren't real and that the square root of zero is real. And then taking the time to think through the fact that square root of 4 is exactly 2. And so square root of 5 is going to be bigger than 2. So hopefully that helps. If there are any notes to self to make there, I recommend pausing and making those now. And then we'll wrap up with one final question that's a little bit more difficult. This one's not from the 11th edition, the official guide. It's from an old set of GMAT practice tests that's out of print also. But if you start looking for this, if you like get a used copy of the OG 11, it's not going to be in there. But it's a great problem, and a good way to put some of what we were just talking about in the previous two problems together. Again, it's a little complex with the whole parentheses and the square roots. So I apologize if that's a little bit of a large challenge here if you're on the go. But I think you'll find the challenge quite worthwhile. So in this problem, we got a bunch of parentheses and roots again. We've got a giant outside set of parentheses where we're squaring everything that's inside the parentheses that I'm about to read to you. So everything I'm about to read to you is taken to the second power. So the first thing inside that large set of parentheses that we're squaring is the square root of, in parentheses, 9 plus the square root of 80. So again, we've got square roots within square roots here. So the first term is square root of, in parentheses, 9 plus root 80, close parentheses. So we're doing the square root of 80 first, we're adding that to 9, and then we're taking the square root of that whole value. To the right of that is a plus sign, and then to the right of that plus sign is the square root of, in parentheses, 9 minus the square root of 80. So I've got in parentheses 9 minus the square root of 80, then I'm taking the square root of that, and then I'm adding that to the square root of 9 plus the square root of 80. And then that whole thing, that whole sum of those two terms I just read to you is squared. Okay, so I'm going to read that one more time. So the question is, what's the value you get if you square root 9 plus root 80 plus root 9 minus root 80? Option A is 1. Option B is 9 minus 4 times the square root of 5. Option C is 18 minus 4 times the square root of 5. Option D is 18. And option E is 20, 20. Again, recommend pausing and working your way through this as far as you can. I'm just going to hop into my commentary. So the bad news here is a lot of us get this one wrong. About 31% of us seem to get mixed up at some point. But the good news is that it's just a more complicated version of the very first problem we did as the warm-up problem earlier. And if you can bring yourself to FOIL the whole thing, first outside, inside last, then things work out just fine. So let's walk through what that might look like and see if we can cement some of the main keys from our discussion into a skill set that can net you some of these like trickier questions a little bit easier. So I do want to be clear, there's other ways you could get this question right. There's a lot of ways to execute math and algebra and computation on the exam, but I'm just going to emphasize the FOIL thing because I think you'll find it really, really usable, and it transfers to a lot of other similar problems. So we're going to take a page out of the book from a previous Real GMAT Problems episode and make sure that we're well organized visually. And I would, instead of writing the square thing outside the parentheses, I would just write both terms 2 times. So I would write root 9 plus root 80 plus root 9 minus root 80 times, in parentheses, root 9 plus root 80 plus root 9 minus root 80. So I'm just writing that original sum 2 times. And then I'm just going to FOIL. So it's a little bit more complex FOIL, but I'm going to walk you through it. So our first terms are 9 plus root 80 in parentheses, the square root of that thing. And then 9 plus root 80 in parentheses, the square root of that. First terms are the same because we're just squaring the thing we started with. So the good news here is that it's just 9 plus root 80, the square root of that thing squared, which means the radical disappears and we just get 9 plus root 80 by itself. Square root of 80 is what I'm saying when I say root 80. Our outside terms are 9 plus root 80 square root of that thing times 9 minus root 80 square root of that thing. And I'll just let that be for a moment as is. Just kind of let that sit there. Our inside terms are basically the same thing as what we just did. It's 9 minus root 80 square root of that times 9 plus root 80 square root of that. So basically the same as the outside term. And then our last term is 9 minus root 80 square root of that times 9 minus root 80 square root of that. So again, the good news is the radical cancels there and we get 9 minus the square root of 80. And I'd write all those four terms out across a line. And then I can see that the square root of 80 from the first multiplication and the negative square root 80 from the last multiplication is going to cancel out. So I'm going to just cross those out. And then I'll also add the 9 from the first times first and the 9 from the last times last to get 18. So I'm going to rewrite that on a new line as 18 plus all the stuff in the middle from the outside and inside multiplications, just to simplify that if you're on pure audio here. So then we're going to start attacking that piece in the middle in a second, but just wanted to somewhat simplify that. And that's just side note, like a good sign that you're making progress on a problem and you might be on the right path, even if that path seems a little complex to begin with, is I'm like, okay, I'm getting some stuff to cancel out. Maybe there's some hope here. So let's start dealing with the middle terms, which is the 9 plus root 80 square root of that times 9 minus square root of 80 square root of that, and then adding that to itself. So because we basically got the same thing twice, I would probably just combine those on a new line and just put 2 times in parentheses 9 plus root 80 square root of that thing, 9 minus root 80 square root of that thing. That's somewhat good news. I wouldn't say I'm feeling amazing about how this problem is going right now, but I'm feeling positive, like I was saying before. So there's hope. I wouldn't completely jump ship and abandon it. So what's interesting here is they're basically the same term because multiplication can be done in any order. So check out the PEMDAS Math Basics episode, which we should have linked for you below. Let me just check on that. Yes, perfect. Thank you, everybody. We should have that Math Basics episode on PEMDAS, what's called order of operations, in the description if this is a little crazy with the parentheses and the multiplication thing. So this is a point where being solid on your roots mechanics really, really helps. You might recall that the square root of A times the square root of B is equal to A times B and then the square root of that product. So square root of A times square root of B is equal to square root of, in parentheses, A times B. If you don't know that yet, definitely worth memorizing and definitely worth practicing, like I was talking about earlier. But the larger point is the same that I made on the first problem. You just want to practice until you know those basic rules of manipulation extremely well. That way they'll be there when it counts and it comes time to apply them in more complex problems like this one. So I would say if you're unsure how much to practice there, somewhere between 10 and 30 basic questions with the Gen AI should do the trick for you. So let's I guess side note, like don't be afraid to do 100 if you're really struggling. The ROI is definitely there. All else being equal, I guess I have to give some caveats there. I don't know that everything else in your life is going to work out for you to make your dreams come true if you just get, learn basic root manipulation. But like all else being equal, if you learn the roots, you practice well, you have a good plan for your GMAT studies, you'll get a solid score, you'll get into a great MBA program, and you're going to get a lot of stuff that you want. That tends to be how this goes. Okay, apologies for the long caveat there. So let's combine our terms under one root using the square root of A times square root of B is equal to root of, in parentheses, A times B. So that's going to give us 18 plus 2 times, in a giant set of parentheses, the giant square root symbol over 9 plus root 80 times 9 minus root 80. So now I've got 9 plus root 80 times 9 minus root 80 just in one set of parentheses under a big square root symbol. And that's really good news because now I can FOIL again. And I thought this would be a valuable question to talk through because a lot of medium and hard questions on the exam are just like lots of easy and medium questions just strung together in a big row. Like it's like three medium questions is how they make a hard one. So this is a good example of that. And I think it can just re-emphasize the value of some of those basics that I wanted you to take away from today's episode. So here you can see this much higher difficulty level question. Again, about four times as hard. It basically just involves the same skills as the first one, which is good news. So let's talk through the FOIL. 9 plus root 80 times 9 minus root 80. So first times first is 9 times 9. That's 81. Outside is 9 times negative root 80. Inside is positive root 80 times 9. And the outside is, sorry, the last, excuse me, got a typo there, team. Uh, Positive root 80 times negative root 80, which is just going to become negative 80. You might notice that the two middle terms are going to sum to 0. I've got negative 9 times square root of 80 and positive 9 times square root of 80. Again, we can multiply in any order, so I'm just kind of rewriting those to make it a little more obvious that they're the same term. So we can go ahead and cancel those out. And that leaves us with, lo and behold, 81 minus 80, which is, of course, just 1. So I'd like to think the test writers are not without a sense of humor or maybe a sense of irony. So now we've got 18 plus 2 times the square root of 1. And it can be a little wild how much that fairly complex situation we started with simplifies down so much. So, of course, square root of 1 is just 1. 2 times 1 is just 2. And 18 plus 2 is 20, just following PEMDAS there. So that gets us our correct answer, which is option E, as in echo. So clearly a lot more steps than the first problem, but very similar skills, if not the same skills. So I wanted to make sure that all of us had those basics at least known and at least applied a couple times. And that way, as you go forth and you practice with more official guide questions, you should be able to spot these patterns and hopefully get better results with a little bit less effort, even if it takes a few mistakes between now and when you get where you want to be ultimately. I do just want to emphasize that that's how I got really good at the GMAT. I just made a lot of mistakes. I learned from those mistakes over time, and I just kept moving forward as best I could, day in and day out. And I truly believe that if you do the same thing, you'll get where you want to go as well. There's a lot of folks out there who study with the official guide for a couple days or a couple weeks and get 99th percentile scores. And that's amazing. That is amazing. Let's appreciate everybody's differences. Let's value everybody's differences. I'm sure you and I, even if we don't have that magical GMAT test taking skill, that we have other really awesome skills. um, so if there are any final notes to self to make on that last question, again, I recommend just hitting pause and making those notes to self now. If you have any questions on anything we're presenting here, you can DM us at the GMAT strategy on current social channels, or you can email us. Our public email address is contact, CONTACT, at thegmatstrategy.com. As always, my greatest hope is that this material is going to make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, please just head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score much, much faster. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Your contribution to the business world matters, and the more capable you become, the more beautiful this world is going to be. Talk to you all soon.